So good morning, everybody. My name is Brad Chamberlain. If we haven't met before, I'm the technical lead of the CHIUW team. And this is kind of an annual tradition. As Engin said, I start out the conference with a state of the project talk. And this is one of my favorite parts of the year because it's kind of fun to look back and see what's been accomplished over the course of the year. And it's also one of my most stressful because it's hard to summarize the whole year's work in 20 minutes or so. So we'll see how we do. If you got here and you somehow don't know anything about Chapel, Chapel is a modern parallel programming language. It's portable and scalable, so we can run it from laptops up to supercomputers. It's open source and collaborative, so it's developed at GitHub and has contributions from community members, like any good open source project. And the goals are to support general parallel programming, which you can think of as if you have some parallel algorithm in mind and some parallel hardware you'd like to run it on, you ought to be able to do that in Chapel. And at the same time, we want to make parallel programming at large scales far more productive than it is today with status quo technologies. So if we just look at this kind of simple example, this is just a short slide that on the left here, I've got a few simple but important benchmarks written in MPI and OpenMP. In the middle here, I've got those same codes written in Chapel. And as you can see, they're much more concise and clean, and I would argue easy to understand. And on the right, we show the scalability of these up to 9,000 cores, I think it is. And you can see that for cases like the stream triad benchmark, we match the reference version exactly. And for cases like random access, where we can take advantage of key features of Cray networks, for example, we have the opportunity to beat the reference version. Now, of course, if the only thing Chapel we're good at were benchmarks, it wouldn't be all that compelling. But happily, what we're finding in recent years is that there are more and more notable applications of Chapel out in the community. And one of the things I really like about this slide is that there's not just kind of one killer app or one killer application area. We see things like traditional physical simulations up in the top row to things that are more like numerical computations or data science style operations or AI on the bottom two rows. And I want to mention that how I came up with sort of the 5 things on this slide is these are all instances of fairly large and long-lived projects written using Chapel, and ones in which the results are being used for what I'll call real work. So I don't mean to make this list exclusive. Our hope over time is obviously to grow the number of things that could appear on a slide like this. And so if you have work that you think ought to belong in here, or maybe it will next year or something like that, definitely let us know. We also maintain a web page where we advertise projects like this. So if you think you should be there, let us know that as well. And happily at CHIUW this year, we've got a number of talks covering these applications. You heard about the Keynote already. We'll have other technical talks on most of these applications. I believe Dakhil's going to give us a lightning talk, giving us an update since his talk last year. And then I'm going to call out Damien McGuckin and Tiago, because they are 2 people who've been involved with Chapel for quite a while, but I believe haven't really been able to attend CHIUW primarily because of it being an in-person workshop. So we're really happy to have them here this year to talk about the work that they've been doing. Calling out a few highlights from some of these communities in the past year. Arcuda has been one of our flagship apps for the last year or 2. They've really taken to doing some community style events recently. So there was a hackathon recently that you can watch, go back and watch on YouTube. And there's a weekly Arcuda Zoom call that there's a link for here. And I'll make these slides, or I guess these slides are already available. So if you want to find out more about that, follow that link. And that's a weekly call to discuss algorithms, code, and methods. And I think it's a great example of fostering a community around a new open source technology. CHOP, as I mentioned, Tiago's work. The thing I wanted to call out here was they had an HPCS 2020 paper this year that won the HPCS 2020 Outstanding Paper Award. So that's really exciting for them. And I believe that was done in collaboration with Georgia Tech. And I'm pretty sure that that collaboration came about at CHIUW last year, which is one of the things we hope to get out of CHIUW is people meeting each other and forming collaborations that they might not get around to otherwise. And then you already heard a little bit about Champs. That'll be our keynote today. They've had a great paper this past year. They're also collaborating with Georgia Tech, and they've got some really exciting things coming up on the horizon, but I decided I didn't want to spoil their talks. You'll hear more about that later on today. The Chapel team at HPE is growing, and this is something we're very excited about. Last year, we had 11 engineers and something that amounted to about half of a manager's time. And this year, we're at the point where we have 15 engineers plus 2 more who are scheduled to start in June and July. We've now got 1 full-time manager added to our previous half-time manager, and we've got a summer intern because it's summertime. So where we're going here is to try to get to 19 FTEs by the end of the year. We have one open position currently. There's a link here at the bottom of the slide if you're interested in reading about that or applying. We think there's one more to come. And I'll mention that if you do your math, that adds up to 20, which isn't 19, obviously. I'll just mention, so Greg Titus, who's been a long-term member of the Chapel team at HPE and really a favorite member of many of us, I would say, is retiring this year. And so that's why it looks like it doesn't quite add up to 19. So we'll miss him very much and appreciate all his work on the project over the years. And maybe we'll twist his arm and get him to stick around one more year. We'll see. One of our big changes this year, as I mentioned, is we have a new manager in Michelle Strout. If you don't know Michelle, she's most recently been a professor at University of Arizona, and I've listed kind of her academic pedigree here, but I'm not going to talk through that all. Michelle's research focus has traditionally been on compilers and HPC, which is of course perfect for our group. And if you're interested in hearing more about her research and her thoughts on those matters, she's got an upcoming invited talk at PLDI that we encourage you to check out. And then really happily for us, Michelle has a really strong history with Chapel and CHIUW. She wrote a great ICS paper on diamond tiling in Chapel and then presented that at CHIUW in 2015. And over the years, she's been a co-author in other efforts and chaired sessions, been a PC member, and so on. So it was great to be able to convince her to come and manage us because she's got great background for exactly what we need. So this is an outline of my talk. We'll see how well I get through it all. I'm just trying to get to my clock on my other computer here. There we go. So I've just given you a little bit of context, a little bit of information about some of our users and our team. Most of the talk I'm going to focus on our recent releases since the last time we saw you a year ago, focusing on both programming improvements and performance improvements. I'll wrap up with a couple of highlights from sort of outreach and community efforts, and I'll have a little bit of summary at the end. So recent Chapel releases. We've done 2 releases since CHIUW last year. This is pretty typical. We do one in the spring, one in the fall. Both of these releases this past year, the 2 main things they focused on were language stability and performance optimizations. Just calling out another theme for each one of them. Our fall release, we focused a lot on collection types and really trying to get our story better there than it had been. And in the spring release, we worked pretty hard on LLVM backend readiness, where the goal for the next release is to have the LLVM backend used by default in most configurations. We also did one bonus release this spring. This was motivated by some InfiniBand performance improvements that we had made in conjunction with the GasNet team at Berkeley, and some portability fixes for Cray EX, which is the Shasta system you may be familiar with. And those felt like changes that shouldn't really wait until the fall. So we pushed out one extra release this spring. Pretty minor, but pretty important for those platforms. This is a laundry list of contributors who've contributed to our last 2 releases. And I've color-coded it to show HPE employees in sort of the dark blue, and then individual contributors and Google Summer of Code students in purple. I just want to say that we appreciate particularly all of the community members who contribute code back to the project. Obviously, it helps open source projects like ours a lot, and we thoroughly appreciate those who've gone through the effort of doing that, so thanks very much. Focusing on the Google Summer of Code students a little bit more, last summer we had 4 great Google Summer of Code projects looking at Mason improvements, distributed linear algebra, support for Google Protobuf, and improving our sequential data structures. So I just wanted to call out those students, some of whom may be on the call today. And then this year, we've just kicked off Google Summer of Code, and we've got 3 projects we're excited about. The first is support for Go-style channels in Chapel. The second is for a sockets library. And the third is support for matrix exponential computations. So we'll be telling you more about those as those projects progress. If you want to learn more about these, there's a link here at the bottom to the Google Summer of Code website that has brief descriptions of these projects. All right, so when we think about these last releases, let's focus first on programming improvements. And we usually talk about what are the big improvements or changes to the language. And I would say that the biggest highlight since last year is that there haven't been any particularly impactful breaking changes in the language. And that may sound like kind of a negative result, but I think it's an important one. If we look at the last several years of releases, many of these had pretty significant breaking changes, and users had to do a lot of kind of scrambling to keep their code working, both to the classes, and then last year we did a change from 1-based to 0-based indexing, which made most people very happy and a few a little bit less so. But it was a big change. We got through it. And so happily, when we look at the last year of releases, there's nothing that amounts to kind of this magnitude of change. And I think that's sort of a sign that we're finally starting to get the language where we and the users think it needs to be. Now, that's not to say that there haven't been any changes. So This whole effort of stabilizing the language is part of what we've talked about for the last few years as something we call CHIUW 2.0. The idea is CHIUW 2.0 will be a forthcoming release in which we sort of commit to not breaking the core features of the language. And the goals here being to avoid continuing to break users' code all the time, which is annoying to everyone, and also to serve as a point where we can rally potential users to give CHIUW another look if it's been a while since they've taken a look at it. Now, again, it's not as though the last couple of releases haven't had any language improvements or any breaking changes, but I'd say that the magnitude of them, the likelihood that you're going to hit them in your code is much, much, much less significant than it had been in the previous years. And I've got a sort of a laundry list of some of the high-level language changes here, but I'm not going to walk through them in the interest of time. So what remains for this 2.0 concept? I would say on the language side, we're really, really close. Kind of the big thing that stands out is improved user-defined collections. We're also scrambling to try to get constrained generic interfaces ready for 2.0, although if they're not, we're not going to hold up 2.0 over them. And then the third thing here is standard library stabilization, which is a little bit new since last year, so I've got its own slide for it. So last year, we sort of thought we were on the cusp of doing the CHIUW 2.0 release. And what we realized since then was that this CHIUW 2.0 release really needs to involve stabilizing key standard libraries in addition to the language. And the reason for that is hopefully obvious. Like if printf were to change its definition on you, that would be as annoying as having the language change on you. So what we've been doing is taking our key standard libraries and then language features that have library-like interfaces and reviewing those to make sure that we're as happy with those as we are with kind of the core language concepts that the compiler implements. So we've been going through these and reviewing them and discussing them and trying to figure out like what are things we're going to regret in 5 years if we don't change them now. And in bold here, I'm showing the modules we've reviewed so far. But I'll say that with respect to this CHIUW 2.0 release, this is currently the long pole in the tent. And the question is kind of, which of these do we feel like we need to stabilize? Which can we put off until after CHIUW 2.0? And what do we need to address in the short term? How quickly can we get there? All right, so let's change from programming improvements to performance improvements in the last couple of releases. And this is another area where there have been lots and lots of improvements in lots of areas. And in a longer talk, we could walk through these in a lot of detail. But let me just focus on a few key examples as teasers. And what I'm going to do is focus primarily for performance on these two graphs. These are representative of some key themes from the past year that I wanted to call out. The first one on the left is support for compiler-driven optimizations. So CHIUW from the start was designed to support compiler analysis and optimizations that we found to be really useful in previous work we had done. Yet it's only recently that we've started really leveraging that. Most of our performance optimization up to this time has been in the libraries, if you will. But particularly with Engin joining the team, there's been a lot of new work on making the compiler better at looking at code and optimizing it automatically. And I'm not going to talk through this graph in detail, but sort of the short version is the shorter, more elegant version has gotten much faster over time without any user involvement and competes with sort of the more low-level hand-coded version, if you will. Still in CHIUW, though. And then the second theme on the right I want to call out here is portability-focused optimization. So this is another case where CHIUW was designed for portability, but historically working for Cray, we focused almost exclusively on Cray networks. Now, as we've started working for HPE and getting on to sort of larger and larger InfiniBand-based systems, what we found was particularly at super large scale, sometimes our performance was really not where it needed to be. So this represents a performance graph on an InfiniBand system between CHIUW 123 and 124. And again, you can see market improvements here. And it's been great to have this opportunity to catch up on non-Cray systems and get them into better shape. So both of these, again, are just teasers. You'll hear more from Engin and Elliot about these efforts in their talks later on today. And while we're talking about performance, I also wanted to call out Thomas Rollinger is going to be giving a talk later on this afternoon that also has a performance focus. I'm not familiar enough with his work to be able to characterize it here. So we'll look forward to seeing what Thomas has to say. Another performance-related thing that's improved in the past year is memory leaks. So we're now at a point where we're not aware of any memory leaks that are injected by our implementation. Compared to a year ago, we were leaking about 18 kilobytes across our suite of about 10,000 tests in about 34 tests. Now we've only got one test leaking, and it's a test that was designed to leak. So that's why we've got the sort of 8 bytes and one test still remaining here. You know, this may not seem like a big deal, but if you've been following the project, if we go back to when CHIUW began, across our test suite, which was much smaller then, we were leaking 7 gigabytes of memory in like 3,300 tests. So we've come a long way. And you know, if you're saying like, well, that's ridiculous, why were these leaks ever there in the first place? It was kind of a matter of survival for us. This is not what we were being evaluated for. We were trying to scramble to prove our point and stay alive, and we leaked memory crazily as a result. So we're much happier now that we've got that in a better state and can clamp down and keep it in that state. Compiler compile times have also improved over the past year, but I'll say only modestly, and users and we definitely want bigger improvements here. The time to compile a hello world in Chapel, for example, is still ridiculous. There's no opportunity to incrementally recompile. So these are things we're planning on addressing. And from that, I want to turn from the past to the future a bit and talk about two key compiler initiatives that are new since last year. The first one is doing a major overhaul of our compiler, trying to improve the compilation speeds and the scalability as the code size grows, supporting interactive programming and tools, and for the developers, simplifying the learning curve, basically by giving a cleaner and nicer source base to work with. And then the second theme is about supporting GPU computing within Chapel. So code generating Chapel code down to GPUs, which is something that's been done in prototypical ways over the years, but has never really existed in the official releases. And this really fulfills Chapel's any parallel algorithm on any parallel hardware theme. So this first initiative here, Michael Ferguson's going to talk about in just a little bit. The second one, we don't have a talk about today from our group, but you will be hearing work from other groups about how they've been wrestling with programming GPUs within Chapel in 3 different talks today. So next, let me just whip through a few outreach and community highlights in the past year. The first one is in September, we launched a Discourse site. If you haven't found your way over to it yet, take a look at it. It's basically replaced our SourceForge mailing lists, which we're increasingly just feeling ancient and annoying. So if you're not familiar with Discourse, you can basically interact with the community either through a web forum or in more of a mailing list mode where these different categories serve as different mailing lists, if you will. And this is complementary to the other technologies we use like Gitter, Stack Overflow, and GitHub Issues. In October, I was invited to give a packed keynote, which was really refreshing because most of the time I just talk about Chapel and what a great language it is. This was an opportunity to talk more about the details of how do we compile Chapel, both sort of what are the necessary transformations to make Chapel work, and what are some optimizations we've been doing recently, like you'll be hearing about later on today. So if you're interested in more about the inner workings of Chapel, I think this is a great talk to check out. In October, we were also named a Bossy 2020 award winner. This is an award given by InfoWorld to the top 25 best open source projects of the year. And other company that was with us there was Apache Arrow, Drupal, Jekyll, and Redis, all of which I think is great company to be in. So this is a nice honor for us. In November, Elliot Slaughter from Stanford did a really great paper at SC20. I'm not going to be able to do justice to in the time we've got here. But essentially, he cross-compared around 20 different runtime systems to see how they compared with one another. And all I'm going to say here is, if you look at these graphs, Chapel is the green line with, is it stars or triangles on it? The one that's kind of at the top of this curve here, and you can see higher is better. In a lot of the graphs, Chapel really stood out at the edge of the graphs. Here, lower is better, alongside things like MPI and OpenMP and Charm++, which again is great company to be in. So that was kind of, our most exciting takeaway of the paper. I think there's a lot of other really interesting and great stuff about the paper as well, and encourage people to check it out. And then all year, we've had a really significant uptick in download counts, where in recent years, we've typically had 4,500 to 5,500 downloads per release. In the 123 release, we got to 13,000 downloads. And in the 124 release we're in now, we've only sort of spent half that time and we're already past that. So that's been really exciting. And I keep waiting for someone to tell me that, oops, they've set up some script that downloads it every night, and so our counts aren't actually reflecting anything. But so far, nobody's found a flaw in the system. And so we're cautiously optimistic that this is a good sign of growing support for the language. The last thing I want to say from a community perspective is not so much a highlight as a low light. I wanted to call out the passing this past January of Russell Winder. If you didn't know Russell, he was a beloved figure and mentor in the UK programming community, very much a programming language enthusiast, and a steady advocate for Chapel over many years, from his kind of quiet position as sort of a armchair enthusiast and, hey, maybe people should be looking at this. I put a couple of nice quotes from him I like in here. The second one in particular, so we've got languages like Rust, D, and Chapel. My contention is that as Python programmers, we should not be rejecting these languages. We should actually be looking to use the right language for the right purpose at the right time. And I think that was really prescient given the ways we've seen Chapel and Python used together in projects like Arcuda and the Cray AI work. If you're interested in hearing more from Russell directly, he had a series of 3 great PyCon UK talks that were primarily focused on Python, but each had sort of a nod to Chapel in the way. One of them had a great mic drop moment. So they're fun talks. I encourage you to check it out. I just want to say that I'll personally miss having Russell in our community. So wrapping up, we've made a lot of great progress since last year. Language stabilization's in good shape, a lot of great performance and portability improvements, and great accomplishments in the user community and in our interactions with the community that you'll be hearing about today. There's obviously a lot of work remaining. I've listed out some of our current priorities here: hiring up to our full headcount, stabilizing the libraries, the compiler revamp and GPU code generation projects I mentioned, continuing to tune for Shasta and InfiniBand. And then on the community side, I think I said this last year as well, but we're really devoted to creating a Chapel blog this year and revamping our website, and obviously continuing to grow the user community. So the last thing I want to say is, if you're doing applications work in Chapel, I'd like to point out this workshop at Supercomputing in the fall, PA ATM, which is all about applications work being done in alternatives to MPI plus X. Chapel's obviously, we think, a great alternative to MPI plus X. So if you're doing applications work in Chapel, please consider submitting a paper or talk to this workshop. The deadline's coming up in sort of mid-July. And with that, that's what I've got for you for the state of the project this year. Looks like we're just a little bit over. We do have a 15-minute break. So I'll maybe defer to Engin to see whether he'd like to do a few questions now or sort of officially call the break, and I can take questions informally during the break.
I am not seeing any questions on Slido at the moment. So
maybe this is just a good opportunity to remind people, if you aren't logged into the Slido yet, the URL is sli.do/CHIUW2021. You can find the link in Engin's slides, which are available on the workshop website. And again, that's how we'll be managing Q&A today, just to kind of keep things a little bit organized, I guess. All right, great. So let me echo what Engin said earlier. We're really happy to have you all here at our first, intended to be from the start, virtual CHIUW. And we're looking forward to interacting with you more later on today. And I think, Engin, just to make sure, I think during these breaks, our intention is that if people want to chat in the chat or unmute or whatever, that that's totally fair game, and then we'll kind of clamp down on things as we get into the next session. Is that right?
That's right. Definitely feel free to unmute and speak up. But before we do that, there are some questions that are trickling in for you, or in general. One is, what is the ETA for the GPU support?
What is the ETA for the GPU support? I think that's a good question, and I think it'll be kind of a thing where it'll become more and more capable and powerful over time. So I didn't really call it out in this talk, but in our last release, we actually did have a Chapel program that compiled down and ran on GPUs, but it came with some pretty significant caveats. Like, it was fairly ugly and low-level Chapel code, and code that we ultimately don't want users to write. So if I pop back to that slide, sort of the code example here is kind of where we want to get, where you use typical things like for all loops to write GPU computations, and use typical on clauses to say in one way or another, like, run this on the GPU. So we don't have anything like this running yet. So there's a little bit of GPU support, but it's thin and it's ugly. Our goal is to basically work with users to identify key kernels and idioms that are of interest to them. The Champs team is one such team we've been working with. You'll hear more about their use of GPUs later in Anthony's talk. And so I think over time, what you'll find is that the kinds of idioms and the cleanliness of those idioms will improve. But my personal hope is that we'll be able to start writing things that are stream-like this in the next release, although it may still not be quite as pretty as this. And it'll just hopefully improve over time from there. Yeah, thanks for that question. Engin, are there other questions you want?
Yes, I was trying to unmute myself.
Okay.
What will be the things the Chapel blog will try to encompass?
Yeah, that's a great question. I think we want the Chapel blog to fulfill a lot of roles, but I think the most important one is that, currently we have this annual meeting, which is great, but only comes around once a year. We've got social media, which is great, but it's a little bit like, does anybody really keep up with all of the social media channels that they would like to? So I think it's sort of like a stream that's constantly flowing by and you might miss things on. And I view the blog as sort of being an opportunity to get a little bit of a coarser granularity and a little bit more contentful content out there on more of a regular basis. So when we think about it, I think it'll be a little bit of editorializing. I find myself reading related work sections and papers and saying, this is a really lazy and ridiculous way of dismissing PGAS languages. So I think we'll sort of take stances on things like that. I think we'll use it as an opportunity to highlight technical achievements as they happen, like performance improvements or new language features. And then I think we'll also try to be using it for a little bit of kind of a how to, like, here's kind of an idiom that I was trying to write the other day. Here's how I did that in Chapel. Or here's something you might be trying to do. Here's how I accomplished that. And then the last one is we've got some historical blog articles, which I think would be interesting to dust off and see how they've stood up over time, sort of taking a strong stance about why Chapel and why do we do it this way. So I'd like to kind of resurrect some of those and put those on the blog as well. But that's our current thinking. I'll mention we're also hoping for community involvement for the blog and community contributors. So if you're doing work in Chapel and would like to write a short blog on it and contribute it, once we've got that up and running, that would be really exciting to us as well.
Next question, and this is kind of a follow-up to the previous GPU one. Also, what GPUs, NVIDIA or AMD or both?
Yeah, so I think, in any parallel algorithm on any parallel hardware kind of story, I think it's crucial for us to support both, or both and anything anybody else comes out with. So to that end, I mentioned we're working on enabling the LLVM backend by default, and we view the LLVM backend as being a crucial component in sort of being as vendor agnostic as possible, in the sense that my sense is that anyone who's doing a GPU or accelerator of interest is investing heavily in LLVM. And so if we can speak LLVM and they can speak LLVM, that's going to make it, I won't say trivial, but certainly much easier for us to code gen for GPUs without worrying about the ins and outs of each architecture. And as many of you are aware, there are a lot of projects designed to try to help soothe this pain, if you will. It's also obviously key for us to support any kind of vendor GPU, just because, we're in the business of building systems with whatever GPUs people want. So, it'll be as vendor agnostic as possible. And our hope is that that'll be one of the big things that will help draw people into Chapel as the support comes online. Is I think GPU programming, as many people as do it, is still pretty painful and kind of yet another dialect to learn. And if we can really unify it with existing Chapel features for locality and parallelism, as shown in this little example here, personally, I've got to think that that's going to relieve a lot of pain and suffering in users. And so we hope it'll be a nice uptick in interest in Chapel as well, if we're successful there.
Next question. Are there any opportunities that M1 processors open, particularly for Chapel?
I'm sorry, I didn't understand that or catch it.
Are there any opportunities that M1 processors, I believe referring to Apple's processor?
Oh, M1 processors, I see.
Particularly for Chapel, yeah.
Yeah, that's a good question. We don't have ourselves any apples yet with M1 processors, or at least none that I'm aware of that we're running. We're definitely not running regular testing on them. In the name of portability, that's obviously important to us. We have run on non-x86 processors over the years. So ARM, for example, is something we've targeted. And that suggests that I think, as far as I know, we should be able to run on M1. But we have been going through some pain points. So the GasNet team at Berkeley has been doing some testing recently of Chapel on M1 processors, and there have been some pain points there. So I think that's a platform we need to get access to and start making sure that we work out any portability kinks that are there. But I don't see any inherent challenges to supporting M1 or other sort of conventional CPUs as opposed to accelerators, if you will.
Thank you. Next one. Do you have any comments on native profiler debugger support? For large code bases, this will be crucial.
Yeah, so right. So as far as tools go, our group is still not doing much there. We're basically keeping busy full-time, working on the language, the compiler, the portability, things like that, and some of these new initiatives. And tools are sort of this classic chicken and egg problem where you can talk to tools communities and they'll say, yeah, we'd love to, but we're going to wait till a lot of people are using your language. And then of course, there are users who aren't going to use the language till their tools. One effort that I'm aware of is at Western Washington University. I know there have been some student projects in recent years that have been looking at supporting more of a coherent GDB-based story for Chapel correctness debugging. I've been talking more to the current crop of students working on that project than I have in previous years. And I'm really encouraged by kind of where they are so far. And I think they've got another 6 months or so on that project. So I think there's a little bit of hope that something will come out of there. Performance tools to me almost feels like lower hanging fruit. And for the most part, I think we've been unsuccessful at encouraging or finding the right people to work on that within the broader community. I think Richard Barrett at Sandia has been thinking and working in that area in general. And maybe we can ask him a little bit more about that in the lightning talks or open discussion session later on today and see if he has anything he could share. But I guess I'll say I agree with kind of the motivation behind the question, which is this is important and kind of a missing component in our ecosystem. And if there's something we could be doing to better encourage those kind of efforts to happen, please let us know. And I'm noticing we've got about 4 minutes left before the break is technically over. I'm doing fine, but I also don't want to deny people their break. How are you feeling about that?
Yeah, I do not see any more questions coming in. Only there was a single comment that the Qthreads team is working on ARM64 optimizations that the Chapel can benefit from. I believe that's in reference to M1 processors question. I just wanted to say it out loud. It's on Slido.
Yeah, great. I appreciate that.
And as you said, we have 3 more minutes for the next session. So we should probably wrap it up.
Okay. So thanks very much again for attending CHIUW. Again, we're looking forward to interacting with you guys throughout the day. And yeah,